Equivalent linear expressions lesson. Let's look at the lesson objectives and the content objectives for this lesson. You will be able to add and subtract linear expressions with fractional and decimal coefficients by combining like terms. You will be able to simplify expressions that include the distributive property, multiple variable terms, and negative numbers. You will be able to apply properties of simplifying expressions to contexts such as perimeters and areas of triangles and rectangles. You will be able to determine whether two expressions are equivalent. You will be able to write equivalent expressions for linear expressions. For the language objectives, hopefully all students will be able to say, or you'll be able to say, I can read to clarify the terms equivalent expressions and to learn how to identify equivalent expressions are equivalent. I can explain how to simplify expressions using the terms commutative property, associative property, and distributive property. I can discuss and describe errors using complete sentences. I can articulate and follow the steps for using substitution to check for equivalence. I can write two equivalent expressions and use the properties of operations to explain how they are equivalent. The prerequisite skills. Identify and apply order of operations and properties of operations to expressions involving positive numbers. Identify constants and variables in expressions. Compute with rational numbers. Now let's look at the lesson vocabulary. Equivalent expressions. Those are expressions that have the same value for every possible value of the variable. And let's review the following key terms. Coefficient, a number that is a factor of a variable term. We will go over that. We'll break those down. Constant, a term that is a number only with no variable factors. Evaluate, to find the value of an expression. Factor, a number, variable, or expressions that is part of a multiplication expression. Term, a number, a variable, or the product of a number and a variable. And then variable, a letter that stands for an unknown number. Let's look at the learning progression. In grade 6, students learn to represent situations with expressions and equations. Students also learned how to determine if expressions are equivalent. In this lesson, students gain a better understanding of what algebraic expressions are and specifically that they can represent concrete situations. Students learn that just as there are different ways of accomplishing an end result, there are different ways to represent that process. For example, in finding the perimeter of a rectangle with width W and length L, you can find the sum of the measures of all the sides, W plus L plus W plus L. Or you can find the sum of the measures of the lengths and widths, 2W plus 2L. Students learn that these are equally valid or equivalent representations. In grade 8, students will learn to solve equations with rational coefficients and interpret the solutions of a linear equations in context. Let's use what you know. In previous years, you learned how to write expressions in many different ways. Take a look at this problem. For example, Micah and 3 friends bought a total of 4 bags of pretzels and 4 drinks at the snack stand. If a bag of pretzels costs X dollars, we don't know how much, and a drink costs Y dollars, again, we don't know how much, what expression could you write to show how much the friends spend in all? Here's some questions to help you answer this question. Use the math you already know to solve the problem. Question 8. Suppose each friend bought 1 bag of pretzels and 1 drink. Write an expression to show how much they spend in all. Question B. Suppose instead that one friend bought all 4 bags of pretzels and another friend bought all 4 drinks. Write an expression that shows the total cost. Question C. Suppose one friend decided to pay for a bag of pretzels and a drink for all 4 of them. What expression could you write to show the total cost? Question D. Explain how the first 2 expressions are related. And then last, question E. Explain how the last 2 expressions are related. So right now, pause this video and do your best to solve these questions. And then when you unpause, we will go through them and you will see the answers. So let's look at question A. Again, suppose each friend bought 1 bag of pretzels and 1 drink. Remember, there's 4 of them. Okay, and they gave you the variables x and y. So here's one friend buying it. X plus y, right? 1 bag of pretzels, 1 drink. Plus the second friend buying 1 bag of pretzels plus 1 drink. Plus the third friend, plus the fourth friend. Okay, hopefully that makes sense. Each person bought 1 bag of pretzels and 1 drink. And then you add them all up. Okay, because it says how much did they spend in all. Okay. Let's look at question B. Suppose instead of that one friend bought all 4 bags of pretzels, another friend bought all 4 drinks, write an expression that shows the total cost. Hopefully you got this. 4x plus 4y. Because the x stands for the bag of pretzels, and one person bought all 4 of them. So whatever that value is, you multiply by 4. And then you would add the 4 drinks that he bought. Okay? We will make that connection very, very soon with those 2. Question C. Suppose one friend decided to pay for a bag of pretzels and a drink for all 4 of them. What expression could you write? So watch this. Bag of pretzel and a drink for all 4. So you add these 2 and then multiply by 4. Now let's look at question D. Let's look how the first 2 expressions are related and see what explanation you gave. This is one explanation. They are the same, obviously. If you add up the x's and y's in the first expression, you get the second expression. Let's go over that and break that down for you. So watch. For letter A, you have the x plus y plus x plus y plus x plus y, and again plus x plus y. Okay, we can put those parentheses just like they did to separate each person. Okay, and the reason they are the same when you add them is because when you add like terms, or excuse me, you can add like terms. Okay, how many x's are here? 1, right? How many x's are here? 1. How many x's are here? 1. How many x's are here? 1. These are all like terms. So 1, 2, 3, 4. When I simplify them, I get 1x plus 1x is 2x plus 1x is 3x plus 1x is 4x. Now I'm going to give another example so you guys can see that. Okay, plus, then look at the other like term, and we're going to use blue. Y, 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 and y. 1y plus 1y is 2y plus 1y, plus another 1y is 3y, plus another 1y is 4y. Therefore, 4x plus 4y will be the same value as these. Now let's actually plug in numbers to check our work, or to double check to make sure we got this right. I'm just going to make these numbers up. Let's say a bag of pretzels costs $2. So let me put it over here. Pretzels equals $2. Okay, and let's say a drink is $3. Okay, so if you look at it carefully, each person, okay, so each person, it's $2 plus $3, right? Plus $2 plus $3, right? Plus $2 plus $3, and again plus $2 plus $3. Okay, so each person spent $5. 5 plus 5 plus 5 plus 5 will give us $20. So in total, they spent $20 if the bag of pretzels is $2 and the drink is $3. Just made up those numbers. I'm just checking to make sure this works. So now let's go down here. 4 times, remember each bag of pretzels is $2, plus 4 times, and each drink is $3. Now let's do the math. 4 times 2 is 8. Remember, order of operations tells us to multiply first before adding. 4 times 3 is 12. And there we go. 8 plus 12 will give us 20. So that's why both of these will be equal to each other. That's just checking it. So going back to this, they are the same. If you add up the x's and y's in the first expression, you get the second expression. Now let's look at question E. Explain how the last two expressions are related. They're also the same. Excuse me. Either way, the total cost will be the same. So the last two expressions are also the same. And what they did here is they used what we call distributive property. And let's look at how they did that. Okay. So, since there's coefficient 4, remember coefficient is a number next to a variable. Since the coefficient is 4 on both, they pulled that out and they said all you have to do is 4 times the x and then 4 times the y. Okay, and we'll break down even further later on. Remember, if the bag of pretzels was $2 and the drink was $3, right? 2 plus 3 is 5. Order of operations tells us to do parentheses first times 4, and then we go, here we go, we have 20 again.